Hello, I'm Melissa Illingworth, and this is my video about balancing redox reactions using the half reaction method. So here's a reaction. We call it a reaction stem. It's an incomplete reaction and it's completely unbalanced. We want to balance it, and we know that it's in acidic conditions. So the first thing I do is determine the oxidation numbers of everything. That will determine how I split that up into the oxidation and reduction half reactions. So our first reactant, the chloride ion, its charge is the same as its oxidation number, that's -1. Then for this next reactant, the MnO4, it's called permanganate. It's a polyatomic ion. In there, the oxidation number for oxygen is -2 for each of them, times the 4 oxygens that are there, so -8 for all of the oxygens together. Then in polyatomic ions and molecules, the oxidation number of the sum of all the oxidation numbers, so the sum of oxygen plus the Mn has to equal the charge, which is -1. So this Mn atom has to be a +7. Then for our product, starting with chlorate, we have the 3 oxygens all together, that's -6 for the oxidation numbers. Again, that plus the chlorine has to equal the charge. So this chlorine atom is a +5 for its oxidation number. And then the other product, we have 2 oxygens, so that's -4. So this Mn manganese atom has to be a +4. So oxygen doesn't change its oxidation numbers here in this reaction, but chlorine and manganese do. I'm going to start with chlorine. It starts off as -1 in the reactants and becomes a +5 in the products. So this change, it becomes a positive number in terms of electrons. It lost electrons, so this is oxidation. So these 2 items with chlorine are going to be in the oxidation half reaction. And then the other atom that changed its numbers, Mn, it starts off as +7 and goes to a +4. So it got less positive, it gained electrons, and that is reduction. So these 2 items with Mn are going to be part of the reduction half reaction. So we're going to split up these into the 2 half reactions. And starting with the oxidation one, so here's the 2 chlorine species. We're going to balance this reaction first by mass and then by charge. So by mass, we mean balancing reactions in terms of having each side of the reaction have the same number of each element. So chlorine, there's 1 on each side, it's balanced. For oxygen, we need to add more to the reactant side. So the way that we're going to do that is by adding water. This reaction is happening in an aqueous environment. There's lots of water around, so that's going to actually take part in our reaction. So we have 3 oxygens in the products. We need to get 3 in the reactants. We're going to add 3 H2O there. That balances out oxygen, but now we just added a bunch of hydrogen atoms to the reactants. We need to add them to the products to make it balanced. This reaction is happening in an acidic environment. There's lots of hydrogen ions around, and we're going to produce 6 more in the products. So that balances out hydrogen and oxygen. Chlorine was already good, so now it's balanced by mass. Then this reaction needs to also be balanced by charge. So the sum of the charges on all of the reactants has to equal the sum of the charges on all the products. So here for our reactants, it's just -1. For our products, we have a -1 and a +6. So that gives us a 5. So it's not balanced yet. We need to add something to make it balanced. We need to add in the electrons that are transferred in this reaction. And to know how many and where they go, we need to know the oxidation numbers of chlorine. So again, here it's -1, and here it is +5. So that is a difference of 6. So that means there's 6 electrons that are transferred. And to get to this +5 product, those 6 electrons are lost. So also in oxidation, electrons are lost by the item. Anytime electrons are lost, they're separated, so they become a product. So here we have 6 electrons as one of the products of this reaction. So that affects our charge here. So we have 6 positives, 6, a total of 7 negatives. So we have a -1 for our net charge for the products, and now we're balanced by mass and charge. So this is our completely balanced oxidation half reaction. Going to do the same thing now for the reduction half reaction. So here's the 2 things we know are part of it. We're going to balance it by mass and charge again. So Mn, that's already balanced. For oxygen, we need to add more oxygens to the product side. So we need to add 2. That oxygen comes in the form of water. And add 2 H2O here. Then we just added some hydrogens to the products. We need to add them to the reactants to balance hydrogen. So that we're going to add 4 hydrogen ions there. So now we're balanced by mass. Then to balance out the charge, again, we need the sum of the charges. So for the reactants, we have 4 positives and then a -1, so that's a +3. And then on the products, neither of our products have a charge, so that's a sum of 0. So again, to find out how many electrons we need the oxidation numbers. Here, this Mn was +7, and then it's +4 in the products. So that's a difference of 3. There are 3 electrons. So to start off at +7 and end up at +4, those electrons are gained. So the reduction is gain of electrons. So those electrons are gained at Mn plus, and at MnO2, it already has those electrons. Those electrons were a reactant. So in a reduction half reaction, we see those electrons as a reactant. That's a good way to remember it, reduction reactant. So we have 3 electrons right there. And then that affects our charge. So we have a +4 and a total of -4, so that cancels out to 0. And our reaction is now balanced by mass and charge. And this is our complete balanced reduction half reaction. Now we're going to combine it with the oxidation half reaction. And here they are written together on the same page. And we want to combine these reactions so that the electrons cancel out. We cannot have electrons being produced and going nowhere and electrons in the reactants that are coming from nowhere. We have to have an equal number of electrons in each reaction. So our top one has 6 and the bottom reaction only has 3 electrons. To get these reactions totally balanced, we're going to take this bottom reaction and multiply it by 2. We're going to multiply everything in that reaction by 2 So that will get us to an equal number of electrons in each reaction. So on the next slide, I have that already written out, where I've multiplied the bottom reaction by 2 and then added them together, so that I have a whole bunch of reactants up here in this really, really long thing, and then all of the products down below. So now we have some simplifying we can do. First of all, the electrons, there's 6 in the reactants, there's 6 in the products. Those then just cancel out completely. Then we have water on both sides of the reaction, and we can simplify that down. So the 3 in the reactants get actually cancel out totally, and that becomes 1 in the products. Oh, I think, yeah, that's right. Then we have hydrogens here. We can again simplify them so that there becomes none in the products, and that becomes 2 in the reactants. So after we simplify this, we get it to our very last step when we finally balance them. And I just have one correction to make, that there's now just 1 H2O. And we can see that our reaction is still completely balanced with, here's 2 hydrogens, we have 1 water product, and then there's a total of 8 oxygen atoms here in this reactant, and then we have 3, 4, and 1, so there's 8 oxygen atoms in the product. So this is our final balanced reaction in acidic conditions. Thanks for watching.